And we are back. Back with the part 2. Back with the part 2. Welcome, hi. Hi there. A brand new stream, yeah. It's been such a long time since we streamed last, you know. The last stream was so long ago, it was hard to wait, exactly. But finally, we're back. Hi there, but simple. Has been so long. You could name the stream 701 and get away with it. I know that I could. Make a slash change the stream count. Exactly, that's it. When we will get the daddy make it, that's the European make it. That's the average European make it. Okay, this finished so far. What's next? You can reach everything. So right here, we basically want this to switch to white and render image. Hi there, Flame. How you doing? Welcome back to the stream. Play control, please. Happy. But I have a video to finish. See a fun life, bye. Can you do it at 18? He's not 18 yet. I can see how that would be a misunderstanding there. Happy means Happy has a tradition of scheduling random stuff in the most insane timings. It means at 18 hours. I'm gonna be dead at 18 hours. So on the number line, okay. So now what we need is number line. U keyframe, there we go. 90 this way. 90 this way. And then so on the number line, so we need a line. like this. And at the same point as the camera. Okay, sweet. Sweet, sweet, sweet. Random visiting elderly relatives visiting whom I never met in my entire life. That okay? Well, good luck, Timon. We won't have another funny number stream for a long time. What about 769, 869, 969? What about 777? That's also there. 999 is gonna be this year. And 1,000 is gonna be this year. My goodness. Funny molecule stream when? What do you mean? You mean laughing at funny molecules? We already did that, didn't we? Just laughing at funny molecules. Or making funny molecules, but I don't think my landlord would like that very much. There, render animation. Daptak, you did just say 2 squared plus 2 squared equals 8. So I mean, yeah, that makes sense that 2 squared plus 2 squared equals 8. I don't know why that would keep you up at night. My entire master's project is laughing at funny molecules. What are you gonna do for stream 100? Cry, probably. That's a good plan, I would say. What else is there? Drink. Like, I don't drink alcohol, but for day 1000, that's tempting. What else is there to do? I don't know. I think that's it. Oh my goodness, what happened?
Hello.
Hi there, Flame. Hi there. Thanks so much for joining. Not well, to be honest.
Not well. Why?
This is like, it may not seem like it because, you know, it's the refresh, but this is the 11th hour almost, so.
Is it?
Yeah.
Oh, okay.
Not well.
Damn.
Don't worry, I only have like 10 more hours to go and the video to work on.
Oh yeah, not long.
Yeah, exactly.
You're only halfway.
I'm halfway there. Whose idea was it to like celebrate the 100s this way? I want to fire them. Next time I'm not making
yours.
I'm not doing a long stream next time. I don't know what I'm gonna do, but I'm not doing a long stream. I'm gonna do a real anything other than this. I don't have coffee. I'm doing it caffeine fucking free. I'm feeling. So hi there, Flame. Hi, listen. So basically, I'm fine. Basically, I'm in a bit of a pickle. I'll be honest. In a bit of a pickle. That's because right now I'm working on a math video about constants, and for this month I have. I want to make 3 mid-size videos. The constant video, one video which I haven't planned, I have no idea what that will be yet, and the chemistry video.
Okay.
The pickle
How long is a mid-sized video?
I just spent 10 days on them. Well, on average, 10 days. On my last one, I
Okay.
spent 6, so It varies.
Okay.
But basically, and the chemistry video, I want to be about chemical reactions. That's the one.
That's a very broad topic.
Yes, it is a very broad topic. However, it is chemical reactions, introduction to chemical reactions. So just my last organic chemistry video was IUPAC, in reality, introduction to what organic chemistry molecules will look like. That is carbon chains, functional groups, so on. This one, I want to understand an introduction to this. Therefore, it's mostly just going to be electronegativity. And remember the geometry notes that I made the thing in Blender when it shows, the electronegativity of each one?
Yeah.
Basically playing with that. So
it's like why reactions happen.
Yes,
from,
that's actually
from like a molecule's perspective.
That's actually the title of the video. Why do chemical reactions even happen? It's precisely that.
Okay, right.
And the thing is, I honestly am a bit stuck-ish because the textbook I've been following up on this. Actually, let me pull up the textbook. What am I doing? This is rendering in the background. I don't really need to. Do I have the source? I have it. Oh, it's an OpenStax textbook. It's a really good one because it's really big. The textbook I've been following up on this is right here, I think. Polar reactions. There we go. The textbook is going right away into different kinds of reactions, like polar reactions, examples of polar, then describing reaction equilibria rates, energy changes, so on, radical reactions, all of these things. However, before I go into the specifics, I want to go over the generals. And as such, so far I have one chapter, that is the charge chapter. So basically all reactions in chemistry happen due to electromagnetism, it's all just charge. And this is basically just introduction to the electron cloud representation with blue and red colors to showcase the electronegativity. Do you think I should cover anything else other than that before going into the specifics? So is there anything else that's like a core concept guiding behind the reactions before you get into the specifics of the reactions? Something other than the general electromagnetism.
Well, I mean, it would be kind of the stuff you've covered already about like energy, right? Like the driving force for reactions is they're lowering their energy. So if you can talk about them in that context, then I think it's fine.
Okay, so basically the previous videos from the theoretical chemistry one, and then this one, just the fact that it's electromagnetism and that is like enough background.
Yeah, I think that's fine.
Okay, then question number 2. What do you think I should also cover in this video? Because the thing is, organic chemistry much more. It's not even comparison. You just know organic chemistry, I don't. I feel like that's enough said. Mm-hmm. So you would, and I always believe that the best time to ask a question is when you already know the answer. So, what do you think I should cover when it comes to chemical reactions? This is like the video that I will basically, whenever in the future I discuss any specific chemical reaction, this is the video I'll just link. Like, oh, I won't explain the basics here. This is the video for the basics.
Okay. Let me look through some of my lectures to see like how they structure it, because I'll look at like first year lectures, because that's what I'd call fundamentals.
Brother, do you never, have a break from streaming? Why? it's every day. So why would I need a break? No, I don't need a break. I'm doing fine. I think I was on quantum mech physics. But yeah, how about this one? Number line. There we go. There we go. There we go. Can you do a relaxing stream where you read a book while, I don't know, sunbathing or something? No, I can do a walk stream though. I'm bad at relaxing streams. Because, you know, there are videos to be done. And white, and there we go. I just did a 10-hour Minecraft stream, okay? That's enough rest for a month.
Wait, you have a Minecraft server, right? Like
yeah.
a multiplayer.
Yes.
Is that what you were doing it on?
Yeah. Want to join
at some point.
I have to add you on the whitelist. You will be the only non-patron. Well, except for me, I guess.
Damn.
Yeah. It's the exclusive.
You know, I used to work as an admin on a Minecraft server.
Oh yeah, I do remember that.
I saved up enough to buy a PC. Just from Minecraft.
Which is still mad to me. I was an admin on a Minecraft server for free because, well, free moderate powers. I was abusing them, so, you know.
That was usually the reason most people became an admin on a Minecraft server.
I mean, yeah. Yeah, because most of the time you don't get paid. Most of the time you're just an admin. That's the deal. You have to administrate, but for that you get powers to abuse, so.
A lot of these, like, introductory lectures they're more about molecular structure than about reactions. I guess I should look in organic.
That's my biggest problem with organic so far, is that it's also specific. In theoretical, I really like it because it's like you have an electron. That's it. It's just an electron. What it does, it doesn't matter. It's generalized to the point where you can describe behavior for an electron.
Have you heard of the one electron universe theory?
Maybe I have. I remember the name, but I don't know what that is about actually. All I remember is the name.
Let me pull it up.
Oh, is that there's one electron and it's just in every single electron is that one electron?
Yeah, because it just moves backwards and forwards in time.
Yeah, then I do remember it.
Sorry, you just reminded me of it. It's it's such a funny theory, and you can't prove it either. Like you can't prove or disprove it, so it just exists.
I mean, what I prefer is the fact that black holes are technically elementary particles.
That's because they're infinitely dense?
No, it's because they can be described with quantized numbers, actually. So, just like an elementary... I mean, they... Actually, no, wait. Quantized? No. But they basically are a particle. Why am I explaining it? They're literally an elementary particle. You can't divide a black hole even deeper than this. You can't... Like, black hole isn't made up of anything because it's a point.
Yeah.
So, it is an elementary particle.
It's a point,
and they're basically described using mass, charge, and spin. So basically, like an electron. And I just find it funny you can use them like that because they're a point. So in a way, just like every electron is the same electron from a physics perspective, where it doesn't really matter, it's just an electron. The same thing goes with black holes. So if you have two black holes, the only thing they will differ in is mass, charge, and spin. Because all other information is lost in black holes. It's just funny. It's like elementary particles in that way. Can you do a thing where you buy a whiteboard and teach stuff with markers? I have Blender and Manim. Like I know that markers are good and all, but I think Blender and Manim are a tad better, aren't they?
And we have a Discord whiteboard.
Oh yeah, that's true. We have two, math and chemistry.
I'm looking at this first organic lecture. And it's literally it just starts listing reactions. Like,
Okay, got it.
maybe it's not the first one.
So
Hang
it's,
on.
I mean,
Oh, it's not the first one. Okay, that's why.
so basically my organic chemistry videos will be just bookshelf adaptations, or books, depending on how broad this.
Yeah.
Thank goodness.
I think
OpenStack's
it's
open
in your
source.
interest to do it from a physical perspective and build out of that, which you've been doing. But if you can contextualize what you're saying in like this organic stuff with like an intro to like this is why it's happening from a physical perspective, then that might be quite good.
Okay, I'll be honest, I am, well, I don't know what the right word in this case would be, because that was something I was expecting. I knew that in organic chemistry there won't be much unified background. That's theoretical chemistry. I knew that in organic it's going to be much more case by case.
I mean, it's built on theoretical chemistry, right?
I mean, yeah, but it's in the same way as, like, you know, classical mechanics built on quantum mechanics. Like,
Yeah,
if you increase the size
you can bridge the two. Yeah,
if you increase the size of quantum mechanics, eventually you will get classical mechanics.
yeah.
It's just not. It's not all that useful.
That's like in materials chemistry. It's like you can look at physical properties of molecules, and if you just keep increasing the size of the molecules until they're infinitely big, then you get the properties of the material. That's literally what you're doing.
You just reminded me of something. You just reminded me of. Oh, I don't even remember what that was. Where basically, you had like an. I think it was something with the electron, and it was surrounded by other molecules, and the more molecules you added, the more the effect was like approaching on a certain number, and so chemists just assumed that there were infinitely many molecules around it, because the number is so big, it's practically infinity, which is the most chemistry thing you can imagine. That never change. Want to join the Minecraft server, by the way, because I can add you right away.
I don't actually have Minecraft installed right now.
Oh, I see.
My username is just Flame.
That makes sense. I can add you.
I'm an OG Minecrafter.
Oh, I see. I see how this.
I'm trying to figure out what the first lecture is in this thing.
I'll give up with doxing. Can you not dox me, Valentino? About time. I have specifically asked you to not dox me. We live in a society in which you can't even ask someone to not dox you.
Skill issue.
I'm getting doxed, it's just a skill issue. Cool.
Oh, you should talk about spectroscopy at some point as well. Like all the different types of spectroscopy and how they can tell you stuff about molecules from the physical perspective.
Wait, but that's not spectroscopy, right? That's different.
Spectrometry, you mean?
Spectrometry. My God, the names.
They're basically the same thing. I think spectroscopy is looking at a quality of something, and spectrometry is like measuring a quantity. They're the same thing. It's really.
There is.
I get the two mixed up.
Bloody hell! There's one thing I haven't covered, which is weird that I haven't actually. And honestly, at this point, I don't know if I should maybe wait to cover it from both chemistry and quantum mechanics. I haven't covered the oh my god, the word escaped my mind a second. When you have an electron gets excited and then it emits a photon. And
photoelectric effect?
No, not only that. Electron can.
Emits a photon.
Yeah, I mean the entire group of electron getting excited, emitting a photon, or electron. So electron getting
luminescence.
Luminescence, all of these, yeah, all of them. Phosphorescence,
so like
fluorescence,
and phosphorescence.
Yeah. All of them. I haven't.
My favorite topic, you mean?
But the thing is, I haven't mentioned it. That's what hit me recently. I haven't mentioned it at all in any of my videos. And at this point, I don't know if it maybe wouldn't be better to do a couple of quantum mechanics videos, the short ones, and then just build up to it. Another thing, I know you've seen it in the most recent quantum mechanics video because it bloody sucked. But I can explain from a quantum mechanical perspective how hybridization works. I have that power now, and I feel incredible.
I haven't watched it yet because I've been away from my PC.
I can explain it actually. Hold on, because it's
okay.
It's actually pretty good. I'm actually really happy with this. Okay, so you basically have an electron, right? This is our lovely electron. A wave packet here. It starts roughly around here, ends roughly around here. That's our electron. Basically, is described by a function, right? The function on which we can operate stuff. Now, what is an operator? Operator to a function is what function is to a variable, as I always say. So basically, you can operate our psi function and get another function in return. So you can get the position, you can get the momentum, you can get the energy, you can get all sorts of things. You can also, based on that, get the angular momentum of our wave function. Now, the angular momentum operator will have, I don't know if it's in every case, but it will have the unique property of producing an eigenstate. What is an eigenstate? Well, for a function, actually it's easy to explain with a vector. If you have a vector pointing in center direction, right? You apply some sort of matrix on this, so you have a vector v. You apply some sort of matrix onto a vector, you get another vector, like vector, I don't know, q, or maybe a w, because I can't write a q apparently. So you apply a matrix on the vector and you get another vector. That's simple enough. However, there are certain vectors and certain operations for which if you apply this matrix, you get another vector, but that vector is pointing in the same direction. It's just scaled up. In that case, you can say that the matrix operated on a vector is giving you back a vector scaled back by a lambda. So if this holds, if basically m vector is equal to this, that's basically the eigenvector. This is the eigenvector. That's because after the operation, it stays the same, and it's just scaled up or scaled down, eigenvalue.
Yeah.
The same thing happens with eigenstates, except instead of vectors, we have functions. So psi, I do believe is noted down this way. Psi L operator, so angular momentum, is just equal to, I think it was S psi, but I might be wrong here, where this is just a number. So that's where we get quantum numbers from, because this is the eigenstate, this is the operator, and this is the quantum number, the angular momentum quantum number.
Okay.
And because of superpositions, even though you have a bunch of them, you can get one bunch of boring math for nerds. The point is, this is how you get the quantum number for angular momentum. And so when you have 4 different electrons, each of them is going to have their own... Actually, I'm going to use the video for this, because in the video, it's just going to be quicker. It's much more cleaner.
You're just going to make me watch the whole video?
No, not the video. No. The very last bit of the video. Hold on. Eigenstates, hybridization. There we go. So you have 4 electrons. Each of them has their own corresponding wave function. Then each of them is going to have their own corresponding angular momentum operator wave function, which is equal to this, right? The quantum number. Each of these electrons has their own quantum number. Now, what happens when they combine? If I do remember correctly, sp3, that means 3 of them have a certain quantum number and 1 of them has a different one, right? So basically the question... wait, what are the quantum numbers?
You mean the ones going in? Or what do you mean?
Well, the s electron quantum number of angular momentum. Hold on, I just forgot for a second. Azimuth, that would be the second one. So it would be the quantum numbers of 1s electron and 1p electron. Or 2p rather. No, wait, it's 2s, 2p. I'm an idiot.
Yeah.
So that's one. So both of them have the principal quantum number of 2 and the angular momentum quantum number of 0 and 1, right?
Yeah.
So basically the question is, when they hybridize, what is their angular momentum quantum number?
Yeah.
So how would you answer that?
I just say you average them.
You average them.
Just get a mix. I mean, yeah.
Yeah, but
I get what you mean.
that's the kind of, but it doesn't really make sense. How could you get because quantum numbers have to be integers, right?
Yeah.
So how could you get a new one? Is it going to be 0 or 1? It can't be anything in between. Well, here's the answer to that question. These are quantum numbers, right? When you take your wave functions, when you combine them, I'm just using the C here to combine, you get them back. This no longer fulfills our equation. Because this is a new wave function. We don't know if it's an eigenvalue, if it's an eigenstate. We don't know if it holds. Which means you don't have a quantum number. It no longer fulfills the requirement. Am I making any sense?
Yeah.
Yeah, and so basically that's why when hybridizing, you don't actually have the angular momentum quantum number because it's no longer fulfilling the equation which is needed in order for a quantum number to even exist. It was mind-blowing to me that I finally understand that actually. It's so I got to a chemical thing I didn't understand in organic chemistry. I got to it with quantum mechanics. Quicker than with organic chemistry, may I add.
Well, okay, no, organic chemistry will never explain that. It would just say like, oh, we assume this to be true. That's it. You just assume it and then work with that.
That's actually what I love so much because this doesn't require all that much context. I went through it really quickly right now, and in that video I also went through it really quickly. But it's once I'm actually finished with proper explanation, not an idiotic make-it explanation that didn't explain anything, a proper explanation, you will see that it's like 30 minutes tops of background to get there, to get to hybridization from quantum mechanics. And I absolutely love it. So I'm really curious how long it would take me to get to stuff like phosphorescence from quantum mechanics. Because I feel like I would really like to
Probably not too long.
Yeah, because to be fair, it's not that far off. It's energy of the electron, basically.
It's physical chemistry, so most physical chemistry you can get to from quantum mechanics.
I just feel...
Except for, like, kinetics, but that's kinetics. No one likes kinetics.
I just feel incredible because this is one of the first times when I actually feel like I've gotten somewhere reasonable, somewhere I can actually teach even people who know about this topic. It's good. It feels good.
Yep.
C-sharp minor, what the fuck?
I just saw that.
I'm streaming for 10 hours. C-sharp, can you not? It's an 11th hour for me. Can we not, please? Just go through your sick fantasies. I think you meant ship, but you know what? I prefer it this way. I like it with the typo. Yeah, I shouldn't acknowledge this kind of thing. Yeah, skyrockets.
I'm trying to find the first lecture on hybridization that I had.
Phosphorescence really shouldn't be that far off. It is just energy.
I guess it would start in MO theory.
I do have to do with the spectroscopy though, that you are correct. I have no idea how spectroscopy works exactly.
Well, there are loads of different types, that's the thing.
No, that probably makes sense.
My research is a type of spectroscopy.
I mean, yeah, because spectroscopy is just like measuring of light, right? So,
yeah.
So it would make sense there are a couple of different ways to measure with light, not just
more
one.
than a couple.
It's basically
much more than a couple.
But like, how does a thermometer work?
Off the top of my head, there's like IR spectroscopy, UV vis spectroscopy, NMR spectroscopy, mass spectrometry. What else? Those are like the main ones. Photoluminescent spectroscopy is a really fun one. You just put light in and measure how much comes out. There's a lot.
Wait, you put a light in, you measure it coming out. Shouldn't that be all of it?
Yeah, no, but photoluminescence is specifically about
Quantity.
well, the luminescence. So like you're putting light in and seeing
So only intensity.
like what frequencies it converts it to.
Oh, frequencies. Never mind. I'm way off then.
Well, because if something is fluorescent, for example, you can put ultraviolet light in, and it will emit like green light or something, and so you can measure that with photoluminescence spectroscopy.
That makes sense.
I assume I'll be using it in the PhD stuff if I get to do luminescence. Let me just find this.
Luminescence is excitement of particles, and then some energy shenanigans from there. It's always some energy shenanigans.
Everything is energy shenanigans.
Everything is energy shenanigans. I would argue it's like the whole of everything.
Yeah, it's all science. It's the universe.
All science is energy shenanigans. It is kind of hilarious, actually, when you get into the deep, the deep roots of physics. How energy is just everything. Because I struggle to come up with anything that cannot be just explained with, oh yeah, it's energy. Even the particles, you have quantum fluctuations, they just appear out of nowhere. That nowhere being obviously energy. It's really funny. In spectroscopy, how we figure out what stars are made of? Is spectroscopy how we figure... Oh, sorry, I misread that. Is spectroscopy how we figure out what stars are made of? I would assume so, yeah. But once again, spectroscopy is an incredibly broad term. It's basically... Spectroscopy just means measuring with light. So, yes, definitely that's how we figure out what stars are made of, because what else are you going to measure it with? It really is just like asking how a thermometer works, isn't it?
Yeah,
like, it depends on what kind.
Looking at stars is like you're not putting any light in, so I don't know if that counts. You're just looking.
Oh, so you have to. Never mind. I was wrong then. So spectroscopy means actively measuring with our own light.
Not even sure if it involves light, to be honest, because I'm now thinking of mass spectrometry, which doesn't really involve any light. Like it just hits a detector,
well,
which then releases light.
Way off.
I don't even know what the definition is of spectroscopy. I'm not gonna lie. I just know like all the different types, but I don't actually know the definition. I'm seeing if I can find the first mention of hybridization on anything, any lectures.
I think I'm listening to things way above my league. Not really. It's just that scientists just have... the thing is, scientists are really awful when it comes to learning new languages, and so most scientists don't actually speak all that great of an English, and they just keep pretending that they do, and they just say all these words like, oh yes, spectroscopy. Yes, there was... I definitely didn't forget what light is in English. It's just spectroscopy. Radiant... It's radiant energy, right? I'm not forgetting the name of light. It's radiant energy. Yeah, that's actually where.
I would argue a lot of scientists are very good at English because they just
invent all these words because they forget the actual English ones. That's the reason. Why do you think mathematicians use the Greek alphabet? Because they forget about all the other alphabets. They use the Greek one. Oh damn it! Was that letter? That letter that was like roundish. I don't remember. I'm just gonna write gamma. That's what happens. They're all illiterate. It's looking at the absorption spectrum of an element. Would make sense for a spectroscopy. Would make sense where the spectrum comes from. Energy isn't everything. Is that we made energy everything? That's debatable, Panda, because if if we haven't made energy everything, then energy is a concept after all. So yeah, kind of, but I mean, too philosophical. I don't like it. I've like the fact that you can determine a unique fingerprint of a specific arrangement type of particles by the type of photons it emits or absorbs is such a brutally powerful tool. That sounds powerful. I'll be honest, as I mentioned, I don't know much about spectroscopy. Remco! Oh,
It's very powerful. That's like most chemistry uses it because otherwise you have no idea what you're using. Like you can make a sample, if you don't know what it is, then it's useless. An example. So, how much do you know about what my PhD is going to be in?
Chemistry, right? Did I get
Chemistry.
Did I get that right?
Close enough. Do you, I've told you it's about like rocks,
yes,
and some glowing and whatever.
Well, I mean, glowing rocks, your flame.
Okay. Have I mentioned solid state NMR?
Yes.
Do you know what that is?
No, I remember you mentioning it. I don't know what that is.
Okay.
Although,
no. I mean, yeah.
No, never mind. No. For a second, I felt like I could guess from the name, but then I realized that I don't know what NMR means.
Oh, nuclear magnetic resonance.
I know what it is then. Okay.
It's where you wobble the nuclei.
Yeah, I know what it is. Sorry, 11 hours. You have to excuse me. I know. Okay, yeah. Solid state NMR. That makes sense. Powerful magnet, I presume.
Yeah, so... Oh, very powerful. It's like, I think...
Is that the one that took the pen?
Huh?
Is that the one that you took the pen? That took the pen of one of your...
Oh, that was EPR.
EPR.
That was electron paramagnetic resonance.
Why do you always just have to shorten the... I mean, I get it. You don't want to say electron paramagnetic resonance.
Imagine you're talking to... Imagine you're in a research group where all they do is that spectroscopy. It's like, you're not going to say electron paramagnetic resonance every time.
As I just mentioned, I get it. You don't want to say whatever. You don't want to say it every single time. But you have to excuse me then if I don't know every single combination of three letters.
That's why I say it after I've said the thing.
I'm tired. I'm sorry.
The only difference between NMR and EPR is NMR is wobbling the nuclei, and EPR is like looking at the electrons, and because they're spin active in certain molecules.
Oh,
so one is
makes sense.
And one is electrons.
Okay, so one is going more for magnetism, the other one is going for wobbling charge? Actually, I'm curious now how it works.
Well, the electron one is paramagnetism.
I remember that when you were explaining different kinds of magnets, that's where I remember the paramagnetism from.
Yeah, I always forget which is which after I've explained it, so I would need to go and look again to actually clarify that for you.
But I'm really curious actually what's the difference between them, because that seems like a pretty mighty task to only wobble the nuclei.
I'm going to be honest, I don't know all the details of NMR. I'm going to be looking at it over the summer, I guess, when I actually need to know it. It kind of, from what I understand, it kind of pings the nuclear. So if you imagine the nuclear spin is an arrow pointing up or something, because you've got a magnetic field on it. You do something that pings the nucleus, so you kind of push the arrow to the side, and then as the arrow, because it wants to go back to the direction it was facing, it kind of starts wobbling backwards, and it processes like it wobbles too far to the left and then to the right again, and it kind of keeps wobbling until it stabilizes at the top.
I mean, okay,
can you imagine that?
That makes sense. I just don't, because one of them you said was about the electrons more, right?
Can you repeat that?
That's the thing I confused you. You said one of them, the EPR, was more about the electrons.
Yeah.
Yeah. So I just don't understand how you could like target the nuclei and try to leave the electron unaffected.
Okay,
or the other way.
EPR thing works very differently to NMR. EPR is that whole Zeeman interaction thing. You know where I showed so the electron can be spin up or spin down.
Yeah.
And if you have a magnetic field on it, then the spin up is
the two line
you
graphs.
get two different energy levels.
Yeah.
And then you can measure that energy level using light. You see there's a certain frequency of light that will get absorbed at that energy gap, and you can measure it, and that's what EPR does, which is very different to what NMR does.
That makes sense. But wait, okay, I don't want to take too much time because you were telling me because that's the whole thing to the solid state NMR. That's where we started.
Yeah.
Because
I mean,
I'll be honest, I'm still confused, but I don't want this to turn into too big of a tangent.
I understand EPR quite well. I don't understand NMR very well. Like, I know how to use it, and I know how to read NMR spectra, but I don't know the exact physical what's going on with NMR just yet.
That makes sense. You don't
have the time
need to
look. Yeah, I don't need to yet. I will definitely need to before the PhD starts, but not yet. But what I was saying with the solid state stuff is right now, most like materials chemistry people, like looking at crystals and stuff, they do different techniques that can tell you the kind of overall structure of the crystal. So, I mean, you know how crystal structures work, right?
Mm-hmm.
It's just a repeating pattern with a 3D arrangement. Most of the techniques we have for solid state stuff, they give you an overall structure. So, for example, X-ray diffraction, you shoot X-rays at your crystal, and they bounce off at different angles based on the bond angles in the crystal, and you get a diffraction pattern. So, like spots on your detector with different angles for the different bonds, and that's really good at telling you the kind of average structure of what's going on. But you can't get details on the local structure, which is things like, have you heard of doping in chemistry?
I have of doping semiconductors.
Okay, yeah, it's the same thing.
Okay, then yes.
So that's like putting a small amount of something into the structure, so you have your repeating units of a crystal arrangement that repeat infinitely, but not every one of those units has this extra thing you've added in. So it's only really sparsely distributed across the whole material.
For example,
and so that's like a local thing. It's hard for you to measure, and solid state NMR is like basically the only way to measure this kind of local structure thing. So you can actually look at individual atoms inside the structure and see how they're behaving, which you can't do at all with like X-ray diffraction and other stuff.
It just hit me. Is it basically that meme you sent when it comes to, I want to look into crystals, all these different methods of, getting information about the crystal structure, and like you can do all of them with NMR?
Wait, let me find that. That was a funny one.
I'm only great.
I don't even know if NMR was on there.
Yeah, I thought it was some spectroscopy methods. I know, maybe. I don't know much about
there are
these
two
methods.
Okay, there's one here, and here's the other one. Yeah, it doesn't even have NMR in this one.
No, never mind.
Let me show you. I'll get the other.
Yeah, that's the one. That's the one I meant. You need to click the Raman and all your functional groups. Oh, in the crystal structure. Never mind then. It's just the
Yeah,
crystal
this is
structure.
more. This isn't looking so much at solid state. This isn't looking at materials. This is more like you can do
So
crystallography. So that where it says SC-XRD, that's single crystal X-ray diffraction, and at the bottom, right on the bottom left, and that's this technique I told you about where you're just shooting what was it called, X-rays at your thing.
no,
And so this whole meme is saying that like you don't need to do any of these other spectroscopy techniques. You just do the X-ray diffraction, and it gives you your it shows it in the crystal structure, which is really funny.
can't grow a single crystals. So NMR I'm gonna remember because it's N, it's nucleus, so it wiggles the nuclei.
Yeah.
And EPR I'm gonna remember because it's E, so it deals with electrons. I have no idea what these mean because I can't memorize them for some reason. Magnetic resonance, nuclear magnetic resonance.
Yep.
Oh my goodness, I guess that. Wow, okay, I wasn't expecting to be right. That makes sense. That's what it is. I can also memorize it this way, I suppose. Nuclear magnetic resonance. I guess then I wouldn't have to memorize it. It's even simpler.
Yeah.
And electron paramagnetic rad thing to do. Electron paramagnetic.
You're almost.
Electron paramagnetic. Really big ass magnet.
Think about the other one you just said.
Resonance. Is it also resonance?
Yeah, it's just resonance.
I was trying to avoid. Never mind then. Electron paramagnetic resonance and nuclei magnetic resonance. Wow, that makes sense actually. Nuclear magnetic. Yeah. Wait, that also does make sense. That actually, wow, it's almost as if these names make sense. It's almost as if wow. I could have seen that coming.
Show you,
I'm gonna be flexing so much because I get so many people asking me about NMR. I don't know why, but there's just so many people asking about NMR. And I'm gonna be flexing so hard now that I know what it is. I still don't know a thing about it, but at least I'll be able to say nuclear magnetic resonance, and it's gonna be awesome. That's not a real thing. I refuse to believe that's a real thing. That's not a real thing. Orange project enhanced nuclear induction
spectroscopy. Let me get you the Wikipedia page.
Oh no, I can find it. Don't worry. Oh, that is hilarious. Cross polarization. Wait, no, I want the penis.
It's penis? The same thing. It was named penis, and then it was renamed to CP, which isn't much better, I might add.
Oh, you think CP isn't better? Oh, wait till you hear about. Oh, wait, what was it called? Physics. Wait till you hear about in physics CP violation, which is a thing. Quite important, I might add. But why did you change it from penis? It is a proton-enhanced nuclear induction spectroscopy thing. It's honestly a bunch of killjoys.
Yeah.
Who changed it? Who has the authority? I want to know.
I don't know. It was probably. I think the guys who published it probably thought it was really funny, and then someone else afterwards probably thought it wasn't really funny and changed the name.
Why? You mean to tell me they didn't feel like writing penis for the method of? Honestly, killjoys. No fun allowed. How did you find this information, by the way?
Let me show you where I first heard it.
The Wikipedia is so short, by the way, on it. I would just like to point out it's so unbelievably short. I want the penis, make it 2025. Yeah, clip that. I mean, proton-enhanced nuclear induction spectroscopy.
This is where I first heard of it.
Favorite penis CP technician. How does a penis work? I'm curious now. I want to know how a penis works. It's all I'm asking for. Nuclear ionization from different types of nuclei via heteronuclear dipole interactions. I like understanding a fair bit of theoretical chemistry, because then when you get into stuff like that, these words make sense, which is really nice. I really like it. Like when you hear heteronuclear dipolar interactions, I have never heard that in my life, but I can at least get what it's talking about. It's nice. Heteronuclear dipolar interaction. It's lovely. It's beautiful. Almost as good as medicine.
Two different nuclei. That's all it
well,
means.
Don't ruin the fun for me, okay? Professor Killjoy. I'm just here rediscovering myself a penis, and then you're just ruining the fun for me. Tennis are truly on something when coming up with names.
I'm looking at the last paragraph where it says CP contact times, and if they hadn't changed the name, it would.
One of the
Let me see if I can get these papers for you.
I think something's happening. My phone. Give me a second.
That is a long URL. Why is it so long? Oh, it's copied my token. What kind of URL copies my token?
I'm back. I am back.
Okay, I have a link to the paper, but it uses a token in the URL, so it might not work for you.
Oh.
That's why the URL is massive, because that's the entire token.
Wow.
Does it work?
I'm trying. It did work. That's a short paper. I don't mean to be that guy.
Yeah,
but...
old papers are really short.
You know damn well, they just came up with the name of penis and they couldn't wait. They just threw 2 pages together. This has 3 pages and one of them is just the cover.
It's not even 2 pages, it's like 1 page.
Oh yeah, it is just divided awkwardly because of the cosmetics. It explains abundant spins. Right position of the
Yeah, I'm not going to pretend I understand what it actually says.
Spectrum is obtained by Fourier transformation. Dot. That's okay. End of sentence. I see. No further information. Did they? Okay. This might be just my PTSD. Did they draw these graphs themselves?
Probably not. They're probably just really badly photocopied.
I mean, the 2 spikes do seem pretty, not like pretty real, to be fair. I just realized I keep reading it like one of these gag papers, you know, when you have like solid tar at the end of the beaker found to be the strongest fucking thing in all of chemistry. They're expecting something funny, but it's just a paper. It's just an actual paper of a really advanced topic. Short of no motion like molar counterparts. I mean, the molar counterparts aren't that bad.
Where I'm from, London, like North London.
You're actually yeah, because Flame is apparently British.
British.
Half, yeah, in it. In it. We doxing Flame now too. Please don't dox Flame. I'm just asking at this point. My girlfriend had a dream that she was sent to assassinate Newton, exchanging the apple with a bowling ball. He wouldn't even see it coming. Have a crime. Actually, hold on. So when it comes to growing, because wait a second. Because the way we started this was NMR, solid state NMR, which I now know what it means. When it comes to your glowing rocks project, how does?
Yeah.
Because it's glowing. It's not magnetic. How does that relate?
I guess the NMR is to look at the structure.
Yeah, never mind. I'm an idiot.
The magnetic properties.
I'm an idiot. I just realized it doesn't have to be magnetic. It just needs to a nuclei, which I would say a nuclei is a much more commonly found thing in chemistry than being magnetic in some way.
I think everything has at least one nucleus. But yeah, it's because in these kinds of materials like perovskites, there's a lot of ways the structure affects the properties. So especially atoms can actually move around inside the structure, and you can measure that.
Wait, I'm curious now.
NMR.
When it comes to all of these different methods for getting information about the certain molecule or crystal structure or stuff like this, which one would you say you know the most about?
That's a hard one. It's hard to say because it's like know the most is a very broad
okay
thing.
Yeah, I
like
should probably specify.
You can understand something really well, or you can know the applications really well.
Which one do you know the most when it comes to it, how it works?
How it works?
Yeah.
Probably the one I'm doing for my masters, which is like it's a type of photoelectron spectroscopy.
Okay.
I would say I understand UV vis quite well.
Because I really want to understand how at least one of these works. The thing is, because here's what I'm struggling with, right? The way it seems to me is that for every single one of them, there's like a method. So, for example, you have your nuclei, right? You jiggle it back and forth, and basically it jiggling, well, not it, only you said spin, I do believe, right? Doesn't matter. You jiggle back and forth, and based on that jiggle, you get a bunch of quantities which then tell you something about it. But what I'm struggling with is that you have this big as magnet, right?
Mm-hmm.
And you have a nuclei, which last time I checked, is not very big. It's not that big. How in the name of this little blue marble that we live in could you get any information back? Like with light, I understand. You fire light, you get light back. Measuring light is much simpler. It's a much simpler thing. But with magnetism, how can you just detect anything? Influencing the nuclei.
I think the oscillation. So they're in a big magnetic field, and I think you then add a small magnetic field that will resonate with some nuclei, right?
Yes.
You add a small magnetic field, and this will change. You'll do different measurements with this magnetic field changed, but the overall one stays really strong. Stays massive. So you have a big one and a small one. The small one is what you're changing, and at different values of the small one, your nuclei will wobble different amounts. And I think when they wobble, they produce electromagnetic they produce light, I think. I'm not sure. I think that's how it works. And so you can measure the amount of wobbling from the electromagnetic light, from the light they produce. I think
that does make sense.
I'm not sure though. I'm not sure about the light thing.
That doesn't make sense. I mean, that is pretty okay. It's pretty cool to me that basically, when you're a chemist this way, your job is becoming more and more like a detective because nothing will truly ever tell you. Like, for example, you have piece of glassware with some liquid inside. No equipment will truly ever tell you what's in that liquid. It will just tell you the different aspects of it, different qualities it has.
Yeah.
That's pretty cool. That's pretty cool. You have to figure it out
yourself. It's a whole field called analytical chemistry, which is just like looking at, it's like measuring amounts of things and characterizing samples. So one of my friends his master's project is in analytical chemistry, and his whole project is looking at lead contamination in turmeric samples. And so he's doing a bunch of NMR.
That's really cool.
To try and like figure out, is there lead present in this and this, and it sounds really boring to me, but it can be interesting.
I don't know. It sounds actually really interesting because you you want to make sure that it's lead, it's not anything else. So you basically want to make sure that you can't get the false positive, and for that, in order that you need to account for everything that could be a false positive. Seems really interesting. Calm down, chemistry ain't that cool. A lot of people are scarred with just chemistry in high schools, and then
yeah, it's a shame because I didn't really like chemistry in secondary school either.
What's really funny to me is when Remco said, hold on, let me scroll up, let me find it. What's really funny is when Remco said, oh my goodness, where is it? When did you even join in, Remco? I'm practically there. Never mind, the message is already too old and it got deleted. Or maybe. Oh, I'm only great at avoiding chemistry. I doubt I'll be much help. It's really funny to me when Remco said that, considering that Remco is really into, really good and really into quantum mechanics. And basically, theoretical chemistry is just quantum mechanics with a plus next to it. Just.
I mean, yeah,
it's quantum mechanics, except you deal with electrons. That's basically it. It's really funny because people consider chemistry and physics to be so different when they're really not. They're really not.
They're a very blurred line. I mean, my project is chemical physics. It's literally just on the border between the two. The only difference is if I do my spectroscopy on a molecule, it's physics. It's chemistry, and if I do it on an atom, it's physics. And that's it. That's the only line they draw. They just say if it's one atom, it's physics, and if it's multiple to make a molecule, then it's chemistry. Which is just, I find that really funny.
I feel like it's more, I don't even know what, I mean, to me, the much bigger line seems to be between organic and inorganic and theoretical than between physics and chemistry. Because that's basically...
organic and inorganic is a very blurred line as well, because it just depends on the molecules you're looking at.
I mean organic and inorganic as a group. I still don't know what the difference between organic and inorganic is, to be frankly honest. All I know is that if you have a chain, then it's usually organic. However, you can have certain chains where it's like Schrodinger's chain. You don't actually know if it's a chain or not. What qualifies a chain? Is methane a chain? Well,
you would say methane is organic, so...
Yeah, but add in a couple metals to it, and then it just becomes questionable all of a sudden, apparently.
Yeah. The thing is, the line between, like, organic and inorganic and physical is also kind of blurred, because it just depends on how deep you're looking into it. Like, you can take an inorganic molecule and start measuring what it does. And if you start explaining what it does at some point you get into physical chemistry, but it's not clear where that point is.
Oh, trust me, I know. I know.
Yeah, okay.
I mean, even with methane, basically, if you want to explain why sp3, you need to go into wave functions. It's
Yeah.
It's arbitrary. It's completely arbitrary.
Yeah.
The only line
I'd say, yeah, that the fields are very blurred. I'd say the easiest things to separate are like the actual, the kind of techniques you're using. So like, you can say synthetic chemistry is very separate from spectroscopy. And so synthetic chemistry is just making stuff, and spectroscopy is measuring stuff. But you still use a bit of both in most research. Or like that, my PhD is going to be both because I'm going to be making materials and then also measuring them.
Yeah, I
to
mean,
see
I'm
how they
assuming
work.
if you make a material, you still want to measure it to see if you've actually made
yeah,
it.
You still do, but it's more like if you're an organic synthetic chemist, you're not really measuring much. You're just making a bunch of stuff, and you're doing some simple techniques like NMR and IR to just check that you've got what
That
you
makes
want
sense.
to get.
I mean, yeah, that
Right.
makes sense because if you just make something without checking what you've made, then that's kind of, well, I wouldn't exactly call that the most useful research-wise. Unless every single one of your papers is also included with like a little ampule of what you've made. And like that's so you don't actually know what you've made, but that's your research. Just everyone who signs up gets a little ampule.
I mean, I do think for my PhD, I'm going to be trying to focus very heavily on the physical stuff. But the problem for me is like I really enjoy the physical understanding, but I actually also really enjoy just like being in the lab and making something. So like the summer project I really liked just because I was like making cool glowy stuff. But I didn't really
But
find that any
couldn't
of the
you just
theory
both?
interesting because it was just organic synthesis.
Okay, but what about your electron scattering? The axle.
That's I find the theory and the understanding and like what's going on really fun, but
You're
it
building a
feels like
particle accelerator.
well, yeah, but it feels like what I'm actually like physically doing. I don't find it as fun as like making.
You mean to tell me that when you get there, you know what I think your problem is? When you get into the lab, when you're screwing in the bolts, okay, you don't have
Well, okay, no, most of
Iron
it isn't
Man's.
building. I've done a bit of building. Most of it
Oh,
is
then that's it,
sitting on
yeah.
a computer processing data,
Okay,
which
then
is
that makes
like
sense.
not very fun for me. That's that's where the dilemma is because it's like I like the physical theory, but the actual physical work is just computer processed data. So yeah,
There has to be some sort of perfect
that's
merge
why I'm
of
just
the
gonna
two
do.
eventually.
I found a project that does both, and I get to just try out both and lean
I
more
mean,
into whichever
the
I
thing
find
is,
most interesting.
eventually you will become a doctor, right? And then eventually you will be doing research where you will be able to just pick something more physical, do all the fun things in the lab, and then just get a bunch of students in and tell them, oh no, you need to learn this stuff, and then get them to all the boring stuff. So that's the process, right? That's always how it goes. So you just need to wait until
I
then.
found someone who does. They do the laser stuff using the glowy materials that I'm making.
Oh.
So it would be like my project, but instead of NMR, it would be the actual laser stuff, which I'm already doing, which does seem like a much better fit. But I've already got this project now, so
I suppose, yeah.
I can still just collaborate with them. And if I stay adjacent to some of the laser stuff, then I can always just go back into it.
I
later.
just love the idea of you eventually being so specialized in just glowing rocks. It's I always find it really funny when there was something so hyper specific, that people choose to specialize in, and I absolutely love that for you. You know what it is. It's just glowing rocks. It's.
I mean, I always liked luminescence. Any kind of for me, my main interests are just any kind of interactions of molecules with light. And so in my summer project, that was making fluorescent stuff. In my current project, it's seeing how light induces changes in the molecule and how you can measure stuff in these weird molecules using light. and in the PhD project, it's going to be on materials that do really interesting things with light. So like absorbing it to make electricity or emitting light, and you can tune that kind of behavior and seeing how structure affects those behaviors and that kind of stuff.
I find it funny because when you say, I like it how basically how light interacts with electrons, right?
Mm-hmm.
From a physics point of view, for a pure physics point of view, that would be every chemical reaction ever.
I mean, yeah.
But I know what you mean. I know what you mean. But it's just kind of funny that virtual photons exist, and basically every single chemical reaction in existence is electromagnetism. Therefore, it's just light interacting with them.
But I've always found color theory really interesting. Like,
when you say color theory, you mean I'm assuming chemical color theory, not artistic color theory.
I mean both actually.
Oh, never mind. Egg on my face.
I mean, yeah. I like some colors. But I mean, when I was like learning physics for the first time in like secondary school, I found all the stuff with like waves and light and color really, really interesting. And then that all applied directly into chemistry when I went to uni.
Uranium is a bit. Does uranium actually glow normally? I think only if it's prepared. But I mean, I feel like a lot more things can glow if they're prepared correctly.
I don't think it glows by itself.
Yeah.
So some radioactive stuff will look like it's glowing because it's ionizing the stuff around it. A lot of radioactive stuff is used in glowing things because the radiation will hit a material called a scintillator, which the radiation hits it, and then the scintillator releases light in response. So it's like a phosphor, basically.
Actually, I never thought of that, actually. Oh yeah, it's not gamma decay, is it?
No, it's not.
It honestly just now hit me that it really can't glow this way. Like it can't glow with decay. It can only make stuff glow.
Yeah.
I genuinely never realized that. I'll be honest. I won't try to hide it. It never occurred to me that it really doesn't make sense for alpha and beta decay to glow. Because only gamma is the one with the photon. Even then, you would need some incredible gamma decay for it to decay visible light.
Oh yeah, like the clock hands, the watch hands. So you know those what did they used radium, right? Those watches that had glowing hands on them. Those have radium on the hands, but the actual thing that glows is a phosphor, like a material that will absorb the radiation and then emit light in response. And so if you have a UV torch and you shine it on those watches, they'll glow, just because it's a phosphor that's just gonna do fluorescence.
Actually,
so it's not the actual radium that glows.
Another thing, when it goes to white phosphor.
White phosphor. Wait, what? Okay. When I said phosphor,
no, I know.
A specific compound. Okay,
I mean, I know this is a segue because because I know it's used really often as amplifier, right? For light. Basically, when you
white phosphorus for light.
As amplifying. So, for example, nitrogen goggles.
I don't actually know much about white phosphorus.
Then never mind. I was just curious how, because I know that it's used for. Wait, didn't you? I remember we had a conversation about this when you had the spectroscopy detector thingy, and it was amplifying. Well, yeah, I said amplifying.
Multiplier.
For multiplier, there we go. I was about to say that I said amplifying, you said another word. It was a multiplier. And you mentioned that white phosphor works in a... So it's really incredible how you can tell me about all the different projects and all the information escapes my brain, but I can be like, haha, this one time we had this conversation where you mentioned the photon multiplier. And I remember that segueing into white phosphor.
Wait. So phosphor is different to phosphorus.
Phosphorus.
So white phosphorus is a compound, and
White
phosphor
phosphorus.
means something that emits light in a certain way.
When the decay causes the electron to be excited and emit light, seem to absorb energy from light. It's not really. Yeah, you're gonna make me bring back my.
I don't think the decay affects the electrons like at all. Like it just splits into two
Here's
atoms.
the thing, fun life. When it comes to decays, you have. Can I just get a graphic with all of them? That would be easier. Alpha, beta, gamma. They all have separate Wikipedia pages. There we go. Well, gamma doesn't even have a Wikipedia page. Cool. Basically, when it comes to decay, you have three types. Alpha, beta, gamma. Alpha basically emits helium. Beta basically emits an electron. And gamma basically emits a photon. Now you may notice that only one of them emits a photon. That is the gamma one. And when it does emit a photon, it's not really visible light. As I mentioned, you would need some pretty special kind of gamma decay to get visible light out of it. You would need to prepare it in a very specific way. You can't see electrons, well, you can't see them, but you can't use them as light because they're not light. You can't use alpha decay for it because it's helium. Helium isn't light. So when uranium starts decaying, it can't, none of these decays will actually glow. Decays don't glow. Are you understanding what I'm saying, basically? Hence why it's so weird to me that I never realized that they can't glow. It makes perfect sense that they can't glow. And it makes perfect sense that they can make things glow, because when you chuck an electron into outer space, for example, then yeah, that electron could make something glow. If it's in the right circumstances, so on and so forth. Or gamma ray, actually. I guess that would be easier. Because then all we need is phosphorescence. Beta is an electron or a positron. I feel discriminated against. I'm sorry, Timon. We don't talk about the positron beta decay. Just getting my fruit. There we go. No, okay. Alrighty. You want to talk about this one because this one's neutron to proton. How boring. I mean proton to neutron, sorry. A positron is just a confused electron. Remco, you can't say that. Don't call confused, that's mean. Now would be perfect time for a well-timed question, but I'll be honest, I don't have any. All my questions have been answered. I'm trying to think of one, something that confuses me. I'll be honest, I didn't even expect to understand NMR spectroscopy. Wait, is spectroscopy, right? NMR?
Yeah.
With a magnet? Not gonna question it.
You know, let me just get the definitions.
I mean, technically, wait, no, because it's about the spectrum, not the light. I'm sorry, I'm an idiot. It's spectroscopy. Okay, more about the spectrum. It makes sense.
So the dictionary says it's matter interacting with or emitting electromagnetic radiation.
Okay, that makes sense.
Let me look at spectrometry.
I can see how a big magnet could cause electromagnetic radiation. I can see that now.
Yeah, so the magnet, they have the biggest one in the UK. Wait, do you know how strong like a normal magnetic field is, like in a bar magnet?
Mm-hmm.
Do you know it in Tesla?
Wait, could you repeat that in Tesla? I think
Okay,
I misheard the
a
question.
bar magnet, like a handheld bar magnet, is
No, I mean,
like 0.1 Tesla.
Yes, I misheard the question. I thought you asked me something different. Okay.
So a normal handheld magnet is like 0.1 Tesla, like the magnetic field strength. Um, the the highest resolution NMR machine in the UK is 28 Tesla.
I see.
So it's a bit stronger. 300 times stronger. And so if it didn't have any kind of shielding, then it would like yeet you across the room if you had if you were holding something metallic. But what they have like a whole shielding mechanism that actually cancels out the magnetic field outside the machine, so it doesn't really do much.
28.
Yeah.
Wait. Does Tesla have a unit? A unit Tesla. I mean, not. I mean, does Tesla have a yes? Because there are certain magnetic units. It does. Okay, kilograms per second ampere, second squared ampere. Because there are a couple of magnetic units which like don't have any SI-based units attached to them. They're just scalars. So it's basically a kilogram. It can accelerate per ampere. I'm assuming. No, wait, it's not in relation to time. I'm an idiot. I'm sorry, why an ampere?
Yeah, Gauss is another unit. When I was doing the EPR stuff, I kept having to convert between Gauss and Tesla because they didn't have a standard.
Oh, it's a Newton of power by ampere times meter. But why by meter?
Okay.
So it's 28 newtons basically per each 1 ampere. And I don't know what the meter is for.
No, I don't know.
I'm trying to like eyeball how much it would eat you if you just held a kitchen knife or something.
Right.
Remco, why you never joined Make It Seems Like Flame? That's a good question, Remco. Even Reblax joined. And he's French.
You said that like it's a... You're like, even though he's French.
Yeah.
Get well soon.
I mean, being Rizofo is my least favorite disability. What's antimatter? You just call something like anti-proton. Positron is the only one to my knowledge that has its own name. And this is a damn good name, I do have to say, positron. It's exactly what you expected it is. Positive electron.
I'm not fully British, I'm half British and half Italian.
Wait, what? I knew that you were half British.
You didn't know I was half Italian?
Half Italian, no.
What? Wait, so you knew I was half British,
yes.
And you didn't go and find out what the other half is?
No, I was like... I don't know.
You just thought I'm half a person.
Yeah, I mean, half British... No, you know what it was? You know that moment, like in Breaking Bad, for example, when the main character gets hit with like traumatic news, and everything just goes blank, and everyone just starts just kind of talking all quiet and just going, basically that, right? And there's like a high pitched noise in the background. When you said you were half British, that's basically what hit me. It was
so you got PTSD from...
Yeah, I was PTSD. Yeah, and then when you went into talking about about your Italian heritage, I was just completely way off. Make it a bad friend. I knew it was half British, okay? I knew half of it.
He just thought I was half a person.
I just never questioned it, to be honest. I was like, yeah, Flame, he's half British. That's what I know. I honestly never questioned it. It never...
This really puts into question the whole scientific mindset. I'm not gonna lie.
No, because it never
You just know I'm
occurred to
half
me.
British, you just don't.
No, because it never occurred to me. You know how it's just the thing is whenever my mind had to answer the question of where is flame from, right? It's always the answer. Like in my memory, the bits there were arranged in half British. That was just considered a country, you know. That's it. That's the country.
I mean, yeah, I'm from Britain.
Yeah,
I've grown up in the UK,
exactly.
but my genes, half of them are Italian.
Okay, I see. I don't care about genes. That's the thing. That's the reason. I'm actually eating popcorn with raisins. Oh, ew. Yuck. Oh, sounds awful.
Imagine having to take turns picking up a piece of popcorn and then a raisin.
Yeah, you would need to pick them all out. Why would you mix them in the first place?
And wouldn't all the raisins go to the bottom?
That's another thing, yeah. They're
So
heavier.
you just eat the popcorns first, and then you've just got a bowl of raisins.
Exactly. Honestly, I am so against just mixing raisins with stuff. Just why? You
I
always
think raisins are fine, but like popcorn, I don't see.
No,
how
like
it
in a
makes sense.
cheesecake, for example. That's monstrous. Why would you ever
I
add
think they're
raisins to it?
fine. Okay, cheesecakes shouldn't have anything in them, in my opinion. Cheesecakes
Exactly,
are just
yeah.
nice.
They should just be as is. It's already perfect. And you're just chucking the raisin in there. I'm eating blissfully unaware my cake made entirely out of the cream of goodness, and then it's fruit on the inside. Healthy stuff. Yuck.
You pop the raisins too? What? I'd love to see that.
Wait, can you pop the? Hold on. You can
I
pop
really
raisins.
don't think you can. I don't think that's possible.
Wait, it maybe might kind of be. The reason, I mean, but only kind of. The hard exterior is important because the pressure builds up, and so at some point the pressure inside of a corn kernel basically gets strong enough.
If you pop a raisin, don't you just get a grape? You just,
I mean,
you just go
you
back
do.
to a grape.
Full circle. Just buy grapes. Just don't mix them with popcorn. Just buy grapes. Pick up like 2 bowls, one for popcorn, one for grapes. You can make grape plasma in the microwave, but don't mix it with the popcorn. Why grapes? Why not raisins? I've
Grapes
just
are
seen
amazing.
them. Grapes
I
are
love
the
grapes
best.
so much more than raisins.
Me too. Grapes are the best. Would I really like
I
about?
don't know anyone who would actually like choose a raisin over a grape.
Yeah, because it's you basically choosing a disheveled old, just completely borderline rotten piece of fruit instead of a fresh one. Why? The thing I like about grapes so much is that everyone knows them. It's such a common fruit. But if you didn't, they would look like alien fruit, basically. Like in social media, in pop culture in general, when you imagine an alien planet, when someone's trying to draw an alien planet, something, when they think of a fruit, it's always just grapes. It's always just grapes, except with a different color, like blue grapes or something. Even though these are blue.
Right.
They really just look like alien fruit, the more you look into them.
I mean, they're just orbs. Like,
No, there's also mushrooms. I keep forgetting those exist. Hold on, give me a second. I need to cherry pick my data. Just don't mind me. I'm cherry picking. Give me a second.
like a true scientist.
Yeah. always remember, kids, to look for a desired result and then cherry pick your data to match it. Almost there. Just one more.
Did you see this meme? This is very much a synthetic chemistry.
Yeah, I did. I mean, it's not wrong. Also, the 100 is a fair bit behind the spike. This graph
yeah,
peaks a little bit above 100.
I don't think it's meant to be a super accurate graph considering it's hand drawn.
No, I feel like that is accurate. If you get the 101% yield, I would still pass that. I would be still like, damn, I've done a good
The
job.
thing is, in the undergrad labs, there would always be some group that got like 130% yield. Because what happens is you do your reaction. So at the start you measure the amounts of the things you've got, which is just in like a crystal form or something, or like a powder. You weigh them out, and then you do your reaction and you dry them, and then you measure again. You weigh out the amount of the final product, and that's your yield. And what happens is if your reaction hasn't been like dried properly, then you still have leftover solvent. So like say you did it in ethanol, you'd still have some ethanol left over. And that adds to
magically
the weight.
increase
and
the
so
yield.
Your yield ends up being over 100% because you weigh more than what you should.
130, that was pretty rough.
Yeah. But it's because, like, in the undergrad labs, you only had, like, 2 or 3 hours to do an experiment. And that means there's not much time for drying.
That does make sense then, actually. Never mind, all is forgiven.
Because, like, in actual research, you stick it on the rotary evaporator. You remember the thing I showed you in the lab where it's like a glass thing and it spins around in the water
It's
bath?
basically highly efficient because it's heating it up and it's also vacuum.
Yeah, it just forces everything to evaporate, yeah. So in actual research, you stick it on that for like 2 hours or something, and then it actually just dries.
That's basically what happens when solvent doesn't want to evaporate, and you're gonna make it evaporate. You're no longer asking.
Yeah, you just force it to. You have to. Although there are some really annoying solvents, like DMF just never wants to evaporate. There's some stuff that's hard to get rid of.
That is something we take for granted, isn't it? It's a very lovely thing to have in chemistry that we just take for granted. The fact that you can just have a solvent, you can just have something to dissolve in, and then you can just simply evaporate it away.
Yep. Or you can just be like me and do some solid state chemistry where you don't use any solvent, you just smash them together really hard.
Actually, what's the difference? What's the difference between a very fine powder and a liquid? Is there a difference?
Well, your fine powder would have to be fine enough to be just individual molecules. So it has to be a very, very fine powder.
So
it would just be a liquid at that point.
Yeah.
Well, yeah.
Liquid is just a very fine powder. Hold on, if you grind something that's supposed to be solid into a powder the size of basically single molecule each, right? Does it reform into a solid?
Probably.
Like crystallize or something?
I would think that the intermolecular forces are just too strong for it to like actually be stable as individual molecules. So like it would rather have the molecules kind of bonded to each other than have them just kind of moving around each other. That's why it would rather be solid than liquid.
Actually, if you're grinding it down, then when you're grinding it down, it would be a liquid. Just when you stop grinding it down, it instantly forms back into a solid, because it's basically you have one action which is forming it back into a solid, the intermolecular forces, and then you have like mechanochemistry equipment that's grinding it down. That's turning into a liquid.
Some very advanced equipment to grind it down into.
Yeah, but I mean, all I'm saying is that technically, then you could basically achieve any you could basically achieve a liquid of anything. Doesn't disregard no matter the pressure and temperature. You could just turn into a liquid. You could have room temperature steel at normal pressure, just chilling there. I mean, of course, you won't be able to do anything with it because I imagine. I don't know. I just imagine like a comically large grinding wheel, you know, or like a comically large motor. Is that what mechanochemistry is? I don't know.
It uses these things called ball mills. Usually, there are two types. So
are they exactly what they sound like?
The main things are there are ball mills and there are extrusion thingies. And the ball mills are literally just a compartment. It's ball, like actual just ball. It's literally a compartment that has balls in it. And it just shakes really hard, and the balls are heavy, and they just slam into the sample over and over again.
Oh, I see. I thought it was a ball, like a bowl of cereal or something, but no, it's just balls. Okay.
Yeah, it's literally just balls, and they just shake around.
Mechanochemistry is fun.
So yeah, don't worry. Next year, I'll make sure I show the balls on stream.
No, but can you really blame everyone? Yeah, exactly. I was about to say, can you really blame everyone for saying that when you just join in like, hey, make it. Wanna see my balls on stream? So, I'm doing penis spectroscopy. Give me a second.
But bowling.
I'm honestly glad that when I said ball mills, this is what I got. Because I feel like there are certain things which could be worse. So you know what? Probably because it's singular. That's probably why. Okay.
The other type of like mechanochemistry machine I know the method is called extrusion. I don't know what the actual machine is. But it kind of just has these like spiral gears that have a really, really tight tolerance on them. And you feed the sample in through the top, and it pushes these gears together.
Oh my goodness.
Really tight, and kind of squeezes out the sample at the end.
Mechanochemistry. So you put
the stuff in the beginning, and it just, in this picture.
Mechanochemistry makes me so uncomfortable with these. Basically, have you ever had like extremely smooth balls or something? And it's hear me out. I'm going somewhere with this.
Yeah, okay.
Get your mind out of the gutter. I am going somewhere with this. Okay, you're the one who brought the ball mill. Okay, have you ever had like extremely smooth balls sponsored by Manscaped? And basically, there's no friction between them, but then you add just a little bit of sand, and there's this awful crunching sound whenever you move them around. And if you've ever been in that kind, it's oddly specific. Yeah, it strikes that extremely specific nerve, mechanochemistry, where it's like so uncomfortable because you're basically forcing the chemicals in such a violent way.
Yeah,
it's so violent.
But see, I was at this the uni I'm going to. I was there like a few weeks ago,
right,
for a conference.
I remember.
So while I was at the conference, I like befriended all the PhD students there who were doing like solid state chemistry, and one of them was really nice. He actually showed me around the lab, even though that's technically illegal. He showed me. Well,
don't mention it on the public live stream, maybe.
Well, I mean, yeah. And his whole PhD is on mechanochemistry, like mechanochemistry techniques for doing like pharmaceutical reactions, so like making organic molecules but using mechanochemistry instead. And so he showed me the extruder and the ball mills, which is really cool.
That's cool. I'm honestly a bit upset that I just came up with the coolest idea. We can have basically a room temperature liquid of something that cannot be a liquid, and you just smack that. That's just what mechanochemistry is. If you have a reaction which needs to happen in a liquid, right? However, you don't want to heat up the material for it to become a liquid, you could just do mechanochemistry. That could work to a
Yeah,
degree.
I mean, I don't think it's so much about the size. It's more about the actual force puts energy into the reaction, and that's what you're doing.
I mean, yeah, makes sense. I mean, you need energy. That's why things are liquid at high temperatures.
Yeah,
You need energy
and I think
for it to work.
with this whole mechanochemistry is it's appealing because it's in theory good for the environment because you're not using a bunch of solvents which need to be disposed after. Because solvent waste.
I just love how
quite bad.
How this is the good for the environment option.
Yeah,
I mean you are correct, but
the thing is, so in one of my lectures, one of my nanochemistry lectures, the professor was like talking about ways to make nanoparticles, and he went through like a bunch of methods, and then I was like, well, hang on, isn't there also like mechanochemistry methods? And he clearly does not like mechanochemistry because he was like, well, yeah, but it's advertised as like a green method, but all the energy to make these machines comes from fossil fuels anyway, so it's not actually good for the environment. He was like, he went off on it. And I still put it in my essay and still got 86%, so.
I mean, eventually I can see how mechanochemistry... It's just so upsetting that the best option will be mechanochemistry when we get like solar panels and everything. That's the most efficient we can come up with? Just grinding it together?
It's more... Well, yeah, I don't know how efficient it is.
I would still call it efficient. I would still call it efficient simply because it's general. Like, you don't need a specific chemical for it. You don't need a solvent. Like, consider how much energy it takes to actually get a solvent. You have to go, like, wake up, go to the store, pick one up, pay for it.
Wake up.
It's a lot of energy.
For mine, it was like I had to walk down 2 flights of stairs to the solvent storage room.
Exactly.
And ask them for 2 liters of ethanol or whatever.
Yeah, no, these big corporations actually have specific people that are just made for going downstairs, flight of stairs, and then asking for a solvent. These whole big machines,
they literally had like there were like 2 people who were just sat there in this solvent room, and they would just sit there in front of this window, and you just go up and ask them, "Oh, can I have this?" And then they would go and get it. That was it. Like, that's all they do.
So what I'm hearing is we can have liquid wood. Yes, actually. If you... like, the thing is, wood chippings, right? Wait, what's it called? The wood thing. Did I get it right? Wood chippings? I don't know.
Wood chipper? Like the machine?
No, not the machine. I mean the wood things that you left after you chopped down wood. The little...
Like splinters? Or wood chips? I guess.
Chips, I don't know. Yeah, no,
sawdust. There we go.
Sawdust, there we go. Right. That was the one I'm
I wouldn't call sawdust a liquid.
But it can be.
Well, it's then like...
and then just cue the intro.
Okay, consider nanocrystals. You know about nanocrystals.
Yes.
I've like explained them.
They're big boys.
They can be dissolved, in quote marks. They can be dissolved in solution. Not really dissolved, but they act as if they're dissolved in solution.
Wait, what's the logistics of that?
For all intents and purposes, it acts as a liquid, right? Like it's in a solution. The solution will glow, and it has a uniform color.
Wait a second. When you say dissolved, you mean
it's not actually dissolved.
You mean the nanocrystals get dissolved, or the nanocrystal gets dissolved?
Like nanocrystals. Okay, so the nanocrystals themselves stay intact, but they're surrounded by solvent molecules, so they're stabilized in solution.
Because the thing is, nanocrystals are big, right? They're really big.
Well, they're on the nanoscale.
Yeah.
There can usually be, I don't know how many atoms. It depends on what you're making, but I think in like a semiconductor, it could be like 20 atoms thick or something. I don't really know.
Well,
it's like enough. It would be enough to like count the atoms, but bigger than a normal molecule. And it's small enough that the electron behavior, like all the luminescence stuff, gets quantum mechanics starts to get upset with how small you're making the sample. Because it's no longer like a big material where it's an infinite
quantum dots
thing. Yeah, these are quantum dots. Yeah, nanocrystals are quantum dots.
Quantum dots, my favorite thing. That has the dumbest name. That so makes sense.
And so in those, like, they behave as a liquid. They can be stabilized by a solvent, so essentially dissolved. But some would describe it as a suspension instead of a solution. And so you could call it a liquid, but it's not really a liquid. Like it's still a solid. So it's a matter of definitions, I guess. I don't know.
I'm gonna make it happen. Listen, I am.
I would really, really like to, in the PhD, work on nanocrystals of these materials.
Well, I imagine you would. You are biased.
I'm completely unbiased. What do you mean?
I just imagine you as like the. I just imagine like a research team where just researching something and you're part of that team, and every single time there's a glowing rock, like it is imperative that I take this time to study this glowing rock for science purposes.
Yep.
It is time for me to do some science on this glowing rock.
That's the thing, though. There are a lot of these like materials being made, where they can make them with properties like glowing or something, or they can change the size to affect how the color they glow in. But the actual like mechanism, the dynamics of how that's working aren't known. And so I can be like actually figuring out how they work.
I do have to say, when it comes to you're just trying to justify looking at glowing rocks again, aren't you?
Yeah, I mean, yeah. But...
But I do have to say, when it comes to all the hyper specializations you could pick, the ways light interacts with electrons is probably as useful as it can get.
I think so. Yeah.
I struggle to imagine a more unbiased, exactly. But I struggle to imagine a more useful hyper specialization than this. Maybe.
Yeah.
But
it's very useful for technology, like LEDs, lasers, solar panels.
Even beyond that, you can generalize it to all reactions.
Detectors.
I mean, it depends where you draw the line, honestly.
Yeah.
It does. The only thing that matters is where you choose to draw the line on any given day.
Oh, there was this mechanochemistry paper like a few months ago that I saw where so they did mechanochemistry, but they were doing like a light-induced reaction, so like a photochemical reaction where it needs light to happen. And so what they did is they put it in a ball mill, but then they also in the ball mill put a piezoelectric material, which those are materials where when you crush them, they release light. So I don't know if you've ever seen like videos on YouTube where certain things you crush them up and they actually produce sparks just by crushing them. I think one was like Lifesaver candies from America.
I think I'm familiar. Pop rocks? Poppers? The ones?
Wait. Oh, here's a video.
I think pop rocks different than poppers, I think it's called.
Pop rocks
not pop rocks on you.
In your mouth.
No, not pop rocks. Yeah, poppers. It's basically the ones that you throw and then they explode.
Not those. Those are just explosives.
Okay, well that makes sense. It's American. I get the revolver.
This video is like 15 seconds. You don't have an ad blocker?
I do. The YouTube is fighting it.
Work. Okay.
Yeah. Hit the lights. Watch carefully. The text is. Oh, so it's making sparks when you. Okay, I see.
You crush it, yeah. And so there are materials that that chemists have made that can do that really well. Where when you crush them, they release light. And so what these guys did in this paper is they did this photochemistry reaction with this material in the ball mill, and so as it crushed up everything, it released light.
Oh my goodness!
Reaction, which is insane.
Oh, that is really cool. Wait, hold on.
So smart.
I mean, no. Let's hold on for a minute. Smart. I would say is extremely creative, but Was there an actual reason for it?
It is actually useful. I
mean, I imagine it.
But it was actually useful.
But,
because
I
it
mean-
means you can just do these reactions without actually using like a laser or something.
I mean, I
obviously
imagine
ball
it
mills-
would be eventually, but it's
Yeah.
just so funny to me that it seems like such a walk-around, such an incredible walk-around. Like,
Well, okay,
no,
'cause
we don't
if
want to
you imagine,
fire a
it's quite hard
laser.
to get light into a ball mill.
Well,
right?
I mean, yeah, I do imagine that. However, was there a reason for doing it in the ball mill in the first place?
I think there was.
Okay, then that
I
makes
think It was
sense.
like
Then
a
that's-
mechanochemistry
then that
reaction
is really
was
clever.
Improved by,
Then that is actually
I can't remember.
incredibly clever indeed. Also, I know it. I can't see it, but I would really like to see what the piezoelectric material, I believe, was
well,
called,
I
right?
could end up doing that from doing like.
Wait, it was
materials like that.
piezoelectric, right? The one emitting light.
I
one.
can type it.
Yeah, I would pay good money to see a piezoelectric material in a ball mill, honestly. It would be like New Year's. We need glass ball mills. That's what we need.
Well, you know what? Maybe I'm
Not
actually
even-
thinking of the wrong word. Am I?
Piezoelectric. Wasn't piezoelectric the one that created
Piezoelectric
electric
is about
sparks?
electrons, maybe I'm thinking piezoluminescent. Yeah, that is it. Okay, piezo means force, so it's piezoluminescence, not.
Yeah, piezoelectric. I knew that one from lighters. That's where I had one when I was researching. Long story. Piezoluminescence. So I would pay good money to see a piezoluminescent material in irradiators.
There's triboluminescence as well.
Wait, sodium table salt. Table salt. I'm sorry, table salt.
I don't know. Maybe. Thing is that there are three things. There's like piezoluminescence, triboluminescence, and mechanoluminescence, and they all basically mean the same thing.
Wow. How did emit light? The ground itself, the surface tension grows, so it should be endothermic. Oh, that's not that simple, Timon. I don't know the answer. If only we knew someone who could tell us something about the material that's
someone who
glowing.
studies glowing rocks.
Yeah,
No.
glowing. Damn it! Oh,
That's
how
the thing. I'm not
flamed
studying them
you.
yet, so I don't really know anything about them.
I know you're talking about the piezophotoic. Yeah, I don't know, something of piezo and photo.
Piezoluminescence.
Luminescence.
I think
That's
in
the
the case
second
of the
word for
video you
light.
watched, it was triboluminescence, which is it's basically the same thing.
I know you're talking about piezoluminescence, but I like the idea of you just talking about glowing rocks. Like, oh, I'm not studying them yet. I don't know. Glowing
Yeah,
rocks.
I mean, I
know what they
don't
are.
like. I need to. I would learn loads about them if I wasn't really busy with my masters.
How did
Because
they
I
emit
think
light?
if I start putting all this knowledge in my brain about a topic that I don't need to learn yet, then it's gonna make me do a bit worse on my current degree.
How did it emit light though? We can make an educated guess. We should be said that this would be an educated guess, so take it with a huge grain of salt, which apparently if you smash it is
Ghosts.
piezoluminescent. No, I think it's when you crush it down, the ether energy it gets
Or
released.
the ether.
Yeah, the ether energy gets released, and so
There are spirits within.
yeah.
You know, did I tell you that in solid state NMR, you have to like put your sample at a specific angle to the magnetic field, and it's called the magic angle. It's called like magic angle spinning.
I don't think,
And
but
it's the official scientific name of the angle.
okay. There are worse names in quantum mechanics. You have good quantum numbers,
Oh yeah,
which is
I remember in some of my lectures, the professor would be like, "Oh yeah, and this is a good quantum number," and everyone would be like, "What does that mean?" And they said, "Don't worry about it."
Yeah, because I mean, to me, the funniest thing is how it's said in Wikipedia, because it basically has to be said this way. But basically, or was it just? I think it was just quantum numbers. I find it so funny. Good quantum numbers. Oh, actually, just quantum numbers, right? Good. There we go. Numbers. Oh no, it's
I
not said
remember I
here.
kept looking this up every time it got mentioned, and then I'd immediately forget.
Yeah, because basically, actually, that's a simple explanation. When the corresponding observable commutes with the Hamiltonian of the system, the quantum number is said to be good and acts as a constant of motion in the quantum dynamics. Commutes. Oh, which one was it? There are so many of these prefixes. Not prefixes. Oh, my brain isn't braining right now. Call make it later. Commutes physics. What does commutes mean? Operators commute. Saying if two operators commute, then they can have the same set of eigenfunctions. Oh, well, that makes sense. It commutes with a Hamiltonian.
Oh, I vaguely
Which
remember
operator?
this from quantum mechanics.
Corresponding observable. Oh, observable is an operator. Wow, I kind of understand this stuff. Feels like witchcraft. When the corresponding observable commutes with the Hamiltonian of the system, the quantum numbers tend to be good. Okay, so it's basically Hamiltonian, that's energy. So basically, to boil it down, if you observe a particle, Jesus, I have to be careful here. If you observe a particle, if your observation quantum numbers are the same as the quantum numbers of the Hamiltonian, so read that as energy, your observation quantum numbers are the same as the energy quantum numbers, then that means it's a good quantum number. It doesn't make sense. I mean, it does. I mean, it makes. It would make
my
for
brain
an.
isn't putting the effort in today to work this one out.
I'm on the 14th hour. I'm doing great.
I did a whole module on quantum mechanics, and I don't think I actually got any info out of it. I got through with like 45%, and I just dipped. It's like, yeah, passed, easy.
Actually, wondering what's the most advanced thing in quantum mechanics you've learned about. I'm curious if I would know what it is.
Let me look at the thing is, I kind of like stopped paying attention like halfway through it. So
That's what quantum mechanics does to a person. That's just normal.
Here it is: quantum theory and symmetry. Yeah, part of it was on symmetry. I actually found the symmetry quite interesting. Let's see. Oh, it's making me download. I don't want to download the PowerPoint. Okay, maths for quantum mechanics. And they just taught us complex numbers because I actually had never learned complex numbers.
Really?
Yeah, it's probably because of COVID. They just didn't get to teach them to us. I'm not gonna lie.
That makes sense, but
Matrix multiplication is not commutative. Oh, I remember all this. I don't remember the actual content, but I remember learning it and then forgetting it. Yeah, this is all maths I didn't like. And we had to learn all this for the rest of the module. So that was like, you know, bracket notation as well.
Yeah.
Right. All of that. What's the next topic?
Every single physicist feels so sly when they use the bracket notations. They'll just doing it like a mathematician.
Cool. It does make you feel cool for using it.
Why do organic chemists love working with alkanes? Because they find the reactions irresistible when the pi bonds get polarized. I'm not the organic. I don't understand the joke. I'm assuming it's a joke because it seems like the delivery.
A joint of an operator is defined by the following. Oh my god, Hermitian conjugate. Oh, I remember hating all this.
Okay, I'm making you take a trip down the bad memory lane.
It was like I liked some of what they were explaining, but just every like method to get there was. Oh man. It's like 5 pages on one problem because he writes out all the maths. Oh my god. Oh, like let me just show you an example of like.
I am curious.
It's just, it doesn't look actually that bad when you like look at it, but it's just you just glance at it, you're like, I don't want to do this.
Can I show it on you or?
Yeah, sure.
Oh.
Oh, I was falling asleep in these lectures.
I mean, this one was pretty rough, I do have to say. It is pretty.
Then the next topic, pure versus mixed states. This might have been some statistical. Complete orthogonal basis set of functions. I don't actually know how I made it through this module. I don't know how I got 45%. A wave function conveys a maximum amount of information permitted by quantum mechanics concerning the properties of the states which it describes. Do not care. I remember the Pauli matrices. Okay, this one wasn't that bad. This was like
Pauli matrices, that's how it's pronounced. Oh, I've been mispronouncing it the entire time then.
Have you been calling it Pauli?
Yeah.
I think people use both. Here's our favorite spin diagram.
Yay! It's been.
Okay, this one was fun because it used molecular orbitals. You might be able to make sense of this.
I'll try. I mean, this is the right side is fine, right? We don't need to care about the left side. The left side is just doing it wrong. The right side is.
What do you mean the right side is a diagram? What do you mean?
Yeah, exactly. we can just talk about the right side.
Yeah, this topic was actually easy because the questions they made us do were really easy questions. So I didn't actually like understand half of what he said, but the exam questions were really easy. Partial trace and calculation of net expectation values. This was just adding matrices together. It's easy. Quantum information. Oh yeah, there was a whole topic on like quantum computing, and I'm gonna be honest, I went to the lectures and I didn't absorb anything. He talked about classical and quantum bits, and that's all I remember. Quantum entanglement. Separable versus entangled states. Oh, I remember this. Pure and mixed quantum state. That's the same as. Okay.
I'm so goddamn tired. I know we would do 20 hours.
Symmetry.
I don't think so.
Oh, have you heard of Huckel theory?
Of what?
Huckel theory. It's spelled like...
I don't think so, actually.
Huckel.
Of course it's spelled that way, because it couldn't be spelled any other way.
I think the U might be an umlaut U, like the U with the dots on it.
I was Flame a chemist and physicist at the same time.
I'm not a physicist.
Flame is not a physicist because he wears a lab coat.
I'm technically a chemical physicist in some respects, but I'm not a physicist.
Flame is not a physicist because he wears a lab coat. A physicist
I don't actually wear a lab coat right now.
Well, never mind, you're a physicist. Sorry about that then, I guess.
Because I was gonna say, like, I did pour a solvent like a few weeks ago, but it was actually I didn't wear a lab coat for it. I just wore a shirt. So I just dissolved it in some deuterated chloroform.
They should really like invent something so when you spill something in the lab on it, you can just wash it right away. You won't need on normal clothes.
It's fine.
sounds fine.
So the thing with this quantum mechanics module is it was meant to be a chemistry module, but the actual people on the module, like all the students, it was like 95% physics students. It was like me and 3 other chemistry students on the entire module. And but since it was a chemistry module, it meant they kept trying to relate it to chemistry, and so they would always bring up like an example. I remember there was one lecture where they brought up like ethene and started talking about the molecular orbitals, and all the physics students were like scratching their heads like, what the hell is going on? And so all the chemistry students were struggling because it's just maths, and all the physics students were struggling because the professors were trying to relate it to chemistry and they didn't know any chemistry. And but after that year, they've now switched it to a physics module, and so now it's a physics module that chemistry students can join onto.
I actually really like what Paper said. Instead of trying to understand quantum mechanics outside of quantum realm, why don't we shrink ourselves down and experience it firsthand? I really like it because it lets me segue into a thing that I have a problem with, basically. I am really good at tuning out my inner nerd when I want to like watch a movie or something. So I can just disregard the fact that it's unrealistic. It's meant to be unrealistic. It's fine. But every now and then, movies just try to force like incorrect science into them. And one of my favorite pet peeves is when someone says in any kind of movie, in Avengers, the first one, that's the quote actually, it's a barrier of pure energy. And like, what do you mean pure energy?
They just say it's an energy field.
Yeah, but like pure. What actually struck a nerve for me was that it was pure energy. How? Okay, what is pure energy?
It's just energy. It's just there.
What about impure? What makes energy pure? Is it just, I don't know, pure thermodynamics energy? The air is slightly warmer over there. That could be it.
That's the thing. Technically, my table is pure energy because all the bonds.
Everything is pure energy.
If you just break all the bonds, no such thing as the energy.
There's no such thing as impure energy. What do you mean impure? Like light? But why would light be pure energy? Why not gluons? It's upsets me to the core. Because basically energy means change, right? So what you're saying is that it's a barrier of pure change. That's basically what energy is. It's just change.
I'll call it the capacity for change.
Not even capacity, it's just change. I mean, okay, I guess potential.
Because something can sit at higher
Yeah,
energy.
fair point. I guess potential. Yeah, I guess capacity for change is better. So capacity for change. What do you mean?
It just means if you touch it, you change.
Pure capacity for change. How? How?
Well, the barrier is there. If you stick your hand in, your hand changes. Easy.
Install some lasers in your room and you have barrier of pure energy. Just a visible light. Nothing fancy. Just visible light lasers.
Yep.
Red lasers. You get barrier of pure energy.
What do you think of time travel in science fiction?
I like it. I do.
I really like it.
I love it.
I disagree with what Gemma said.
What did they say?
People talking about time traveling to the past as if it's some science and not just pure fiction. The thing is, like, it's a thought experiment, right?
Yeah.
Did you ever watch Tenet?
No, I haven't yet.
Oh,
it's on my to-do list to watch it.
It is my favorite time travel film, just because they did time travel differently to like most other.
The thing I do have one pet peeve with time travel though, because I love time travel movies. Absolutely do. Time is my favorite thing. I have a list of top 5 favorite things, and it's information up from the least favorite to most favorite. Information, abstraction, space, life, and time. Time is my top 1 favorite thing of all time. I don't know how many people even have a list of favorite things. I do, and time is my favorite thing. However, really often when movies and shows do time travel, they do it in order to tell a story, basically. And because of that, they usually pick time in a way that's very convenient. So, for example, when someone travels to the past, it changes events in the future. However, the events in the future get changed slowly. And why wouldn't they be?
Future, you mean? Yeah, it's like why is it?
Like for example,
why is it happening slowly?
Exactly. Yeah. Like the name of the kid, Marty? No, I don't remember.
Yeah, it's Marty.
Marty? Oh my goodness! Wow, it's been years since I've seen Back to the Future. But when Marty starts disappearing, like
yeah,
he wouldn't.
Like, why is he disappearing?
Yeah,
slowly?
he wouldn't be slowly disappearing. He would just vanish, poof. What's more, another thing.
But then it's like, at what point should he vanish? You know, it's that,
yeah,
like,
exactly. The second thing, as I just mentioned, as I was trying to say, is butterfly effect. He shouldn't vanish when he did something. He should vanish the millisecond they appeared there, because all the molecules in the air are just gonna get just swashed to the side, and that's gonna cause a chain of events. The future is gonna be totally different. Yeah. But that's a pet peeve I'm willing to move past if really it's done well.
Because the time travel in Tenet is
I will.
Is like, instead of just traveling, like instead of just you enter your machine and then you exit at a point in time, what it is the machine inverts the entropy of whatever goes in. And yeah, they do get some stuff a bit wishy-washy about like what the implications of the entropy thing. The whole concept is like, once you're in the machine, you're then moving backwards in time until you go into another machine.
I will watch I will watch Tenet. However, in my opinion, the show is not a movie, but in general, a show that did time travel the best.
Are you gonna say Dark?
And at the same time, it was perfectly scientifically accurate. Was Westworld. I don't know if you've seen it.
Oh, I haven't watched Westworld.
Then it is my favorite show. If I had to pick one piece of media to say this is my favorite, I would pick Westworld. Have you
watched Dark?
I have watched a couple of it, but I couldn't stomach it. It was...
Oh, really?
It was too much for me. I don't know.
Dark was so good. Dark is my favorite.
It was like... It was like too dark. I don't, pun intended, I guess, but I mean, it was like...
You don't say.
You know that feeling of awkward silence?
Yeah.
Well, it feels like they bottled that feeling and then just spilled it over the whole thing. I don't know. I can't describe it in any other way. It felt like... It was really good, I remember, but it just felt like awkward silence to me. I don't mean it was boring. It wasn't boring. It just felt like...
I get what you mean. Like, a lot of the show is like atmosphere and
yeah, exactly.
Like,
that atmosphere crushed me. I don't know why.
Yeah, okay.
It just felt off. I will probably try to rewatch it because I do want to.
You really should, because the whole like time travel thing is like, it's very deterministic time travel, but it works really, really well.
I do want to, but Westworld, especially the first season, I don't think anything... The problem... Okay, listen, Westworld... The thing is, I want to tell you as much as I can about the Westworld, but it's Outer Wilds, okay? It really is.
Yeah.
I can't. It is the best switcheroo, just 360 and a completely unexpected ending of all time. And the thing is, I can already tell you that I don't think you will ever expect. It's just incredible. I want to tell you more, but I can't. It's incredible. The second, third, fourth season fall a bit off, but the first season is...
I don't like starting things where they do a long run and it kind of just falls off.
But the thing is, it starts so strong in the first season that it falls off from like a 10-star show to like an 8-star show.
Okay.
And the fourth one is actually finished, so they're not going to extend it for 8 other seasons. where it just dies. It dies not as strongly as it could, but it's still pretty strong.
Okay. I get kind of intimidated by like really big shows.
Westworld is worth it. Yeah.
Okay.
If I ever
Dark was good because they just did their 3 seasons, which was their planned thing from the beginning. Everything tied up really nicely, and then that was it. That was the end.
Yeah, in Westworld, it's clear that they planned the first season, knowing they'll make the second one. But actually, no, the second one was still pretty well tied up. Actually, it clearly was the first 2 seasons and then last 2 seasons. So there were like 2 lines there. But damn, the first season ending, I was just, listen, I'm a person. It's an unbearable quality of mine. Whenever someone is excited about the movie, whenever I watch it, I try to guess what's gonna happen with all my effort, and I do usually get it right. Westworld is the only one where, when I did guess it, I guessed it like 5 minutes before something actually happened, not 3 episodes before it. Yeah. It's incredibly well made. To be fair, the thing is, there's one, what's it called? There's like one shtick they used for surprising the viewer, and it's clear that in the 3rd season, they are so damn aware that everyone's expecting it, that they actually reverted back. I can't tell you what it is, because it was gonna spoil. It's annoying. I know how you felt I know how Elliot felt, mostly, when Elliot was trying to sell me on Outer Wilds.
I've been playing another game recently called Tunic. Have you heard of it?
Tunic? No.
Oh, it's giving me a similar feel to Outer Wilds in terms of like the information gets slowly trickled, and you like piece stuff together, and it's less
I'll be honest, that's not what I was expecting.
I know it's it's the art style is really interesting, but it's more linear than Outer Wilds for sure. But the actual like info you get gives you the same feel as Outer Wilds, in my opinion. And I think I'm kind of close to the end, maybe, I don't know. And there was this whole like revelation thing, whereas it's like it showed me some info, and I'm like, okay, that's a lot more depth than I was expecting. And now it's got me speculating about like the nature of the entire game. And now I'm trying to like figure out if there's a whole like bigger story to the game.
I might give it a try.
It's really good.
No, the problem with measuring up to Outer Wilds is Outer Wilds is perfect.
Don't compare it to Outer Wilds.
Yeah.
It's a different kind of game. It's a lot more.
Also,
you can see in
Outer Wilds is a perfect game, so I mean, it's
yeah,
kind of mean thing to do, compare something to it.
You played
Don't
the DLC,
spoil
right?
Outer Wilds, please. No, I haven't yet. I haven't gotten to it.
Oh, play the DLC. It's day 700. Just pull up the DLC right now.
Right now? How long is it?
It's like 15 hours.
15?
It's like almost the same size as the base game. It depends. You wouldn't finish it in one stream. I wouldn't want you to. You should not try and finish it in one stream.
I'm glad that you switched right away from you wouldn't finish it in one stream to you shouldn't finish it in one stream.
Yeah, no, you shouldn't. You literally should. You would be in pain by the time you finish it if you did it in one stream.
You know damn well that if you said you wouldn't, then I would.
Yeah, no, you shouldn't.
Two different methods, okay.
The thing, when I was playing it, it's like you have to actually take breaks to let yourself process the information that you've been getting and like process what's going on.
Yeah, to be fair, the live stream has soured a bit. I mean, it's, as I mentioned, it's still a perfect game, so even soured Outer Wilds is still amazing. But
I feel like the way to do it on stream is to like just do a couple hours at a time and then just do something else.
But then I won't be able to sleep at night.
Well, that's the fun of it. You get to lie in bed thinking about Outer Wilds. Is there nothing better in life?
I mean, the thing is, okay, I hate the fact that it's the same with Outer Wilds and Westworld, right? We can't talk about Outer Wilds because we're gonna spoil it for someone. I can't tell you what the revelations in Westworld were because I'm gonna spoil it for you. So it's the same thing again. However, There is also one project which is just going to be Outer Wilds except science this time, and I also find that pretty funny. There is just something about discovering that's just scratches that itch.
Yep.
Outer Wilds just does it so well. Like a game where you're a space historian.
I have really
basically
been enjoying Tunic because it is like a whole discovery thing.
Now we'll also have to give it a try.
It's a lot more combat heavy. Like there's actual combat and stuff. It's presented like Zelda, but then as you get into it, you realize there's a lot more depth and exploration and discovery.
I might have to head out to start playing Outer Wilds. I understand, Stump, I understand. It's reasonable.
That's the thing with streaming Outer Wilds is like, in theory, the only audience for Outer Wilds is people who've already played it.
Well, that's the only audience that should be watching a stream of Outer Wilds.
Yeah.
And that's the problem.
There will still be people who haven't played it that watch it, but then
because every single time
ruining it for them.
Yeah, because I can put all the spoiler warnings I want, but everyone will be like, probably, oh, I wouldn't play it anyway.
I just won't play it. Yeah.
Yeah, but I mean, you would. You really would. You should, at least.
You really should. That's the thing. They should play it. You would rather they play the game than watch the stream, right?
Yeah. Does the main character die at the end of Outer Wilds? Gemma, don't spoil it for everyone. And then they wake up, it was all a dream the entire time.
Yep, John dies in Outer Wilds.
John Outer gets killed by John Wilds.
John Wilds, yeah.
John Wilds escapes and is finally outside.
Did I tell you there was a at this conference I was talking to these PhD students. They were talking about a spectroscopy guy who does laser spectroscopy, and his name is John Beams. John Beams. And he does lasers.
You can't make this up.
It's just so funny.
You did one day. Oh no, this is gonna be one of those moments where it's gonna be something like, he discovers or invents something, something with a laser, right? Like, I know, a golden frequency, for example. Like a frequency that's just perfect for something, and it's going to be called a laser beam, except it's gonna be named after John Beam. John Spectroscopy. John Beam. We just dogged someone, by the way, just completely.
Well, no, okay, they spoke of a guy in this field, right?
I know, but
you could find that by just looking in the field.
It is pretty funny that we're just making fun of someone with, like, we're making fun of them and actually giving the name.
I mean,
John
it's a
Beam.
funny name. Like,
it is a pretty funny name. It's a funny name due to the circumstance. Do you think it had an effect on him, actually? I think
I would imagine there's some kind of like.
Yeah, I imagine it played a non-insignificant role. Not even a subconscious bias, only more like, I don't know, because his name is Beam. People may be telling him about laser beams some more. There can be some kind of non-significant correlation there. Insignificant. Why does Flame's logo look like a red monster with one eye? Isn't that a person just to turn to the side? What do you mean?
It's just a guy.
Gemma, what did you smoke?
It is just a guy.
Milestone. Day 700 my birthday. Happy birthday, Justice. Happy birthday. John Beam, I'm sorry. This.
Have I heard of Control, the game? I think it's on my wish list. Oh, it's... Why is it not on Steam? The Ultimate Edition is on Steam. I've definitely heard of the game.
I think Maker would absolutely love Portal. I'm sorry, I know about the game. I know that the cake is a lie. Spoiler. Hi there, Greg.
I played a funny game a couple weeks ago called King of the Bridge, which is like it took me like an hour to beat it, but it's it was just it's like you're playing against this bridge troll that's like it's meant to be chess, but the bridge troll has this book with all the rules for the game that they've just come up with, and so it's not actually chess, it's just the rules in the book.
But you don't know the rules.
And you have to catch them if they cheat, or you can play around the rules to not cheat and break the rules. It was like an hour. It was just really funny. Like, you know, some indie games, someone just makes it in like a week, and then they just put it up, and it's like £1 on Steam.
Indie games
Just a fun hour.
Are just really fun.
Yeah.
Every now and then, an indie game just blows up over the entire internet, and then just... Wasn't Outer Wild... Actually, wait, what does indie mean, actually? Where was the boundary?
I just say it's like not made by a massive game studio, in my opinion.
Yeah, because in that case, Outer Wild would be an indie-ish game.
No, yeah, definitely. It's definitely an indie game. Have you played The Witness?
No.
Do you know what it is?
I don't.
Oh, really? It's like one of the classic like puzzle games.
The Witness.
But it can be quite slow. It's literally all puzzles. There's like barely any plot.
Oh,
that's
puzzles. The one. I know it is. Yeah. It's a nice looking puzzle game. It's like that one level in Ultra they made it into an actual game. That level in Ultra That was nice. Finally, about time. We have such differing tastes in games, by the way.
I like
one and done. I would describe it.
Atmosphere and like emotion.
Yeah, like a one and done, basically.
Yeah. I mean, I do play Valorant as like I don't know. I don't play many games that will last ages. You know.
I'm the exact opposite.
Story.
I like a good story. Just. Sons of the Forest was nice because it had a good story. The only problem is, even the finished game wasn't finished. So, yeah. That's kind of a pickle. It's so funny because in the finished game, I played with Tefta, and there's like this golden armor, and then you finish a game, and like you still have no idea why it was there. It was just like an alien spaceship with golden armor, you know, in a cave, just there, just a core essential thing you need to go to, and you also kill a demon. Actually, a lot of demons. A big demon. Why? Why not? It's just demons, you know. Make it sound like the kind of guy who would enjoy getting over it. I doubt I would enjoy it.
Chance of Senar was a fun one. Have I told you about it?
I don't think so. Chance of Snar. Or
It's
maybe.
like a language puzzle game.
Yes, and yes, you did. Okay.
Oh, that was so good.
Hold on, I need to go to the bathroom. Be right back. No. Thank goodness tomorrow the stores are closed and instead of buying some food or something, I'm just spending the whole day streaming. Like a responsible adult.
Very responsible.
I don't wanna do 20 streams. 20 hours, I mean. I did 20 streams already. I don't want to do 20 hours.
I was gonna say I might go for now and chill
Yeah.
for a bit and then come back later.
I don't know if you're gonna come. I don't know if I'm gonna be streaming. I'm done. I'm so tired.
You don't need to. Like, no one's making you.
I know. That's the problem, right? The fact that no one's making me. I can just be like, hey guys, you know what? I am done with this live stream. I'll see you tomorrow, and that's it. And over. No one will be upset.
Yep.
Yeah. I'm gonna go. I'm gonna go as well.
Well, I'm gonna go for now.
Before we finish stream, can you play Control Make It? No, Papi, I don't think I have it. Before you finish stream, can you just quickly do a playthrough of one full game?
Yeah, just play the whole Outer Wilds DLC really quick.
Hey, would you mind speedrunning Minecraft while you're at it? Just.
I mean, Minecraft speedruns can be like 20 minutes.
Well, they can be. That's the problem, isn't it?
Yeah, it can be.
Can be. I think that's the pickle.
Alright, I'm gonna go.
Alright, bye, Flynn. Bye. See you.
Thank you for having me.
Yeah, thank you so much for joining in.
Yeah,
bye. Now, everyone, I will also be going because I'm old. I'm tired. Okay, I'm not. It's not what I used. It's not what it used to be. Okay, I'm tired. I'm sleepy, and tomorrow I have to wake up and finish the video. Haha! Tomorrow I'm gonna finish the video. No. I'm sorry, Lucas, I'm sorry. It's been a long day for me. How about this? Tomorrow I'll try to finish the video. Because we're not that far, actually. We're like halfway there with animations. I consider that not far. And I think we're in the range when we can start finishing it up. 5, 6... Yeah, it's not that far. I could knock it down like 2 days. So either tomorrow or in 2 days... Either tomorrow or in 2 days, I'm gonna finish the video. But for now I need to get some sleep because I'm just really, really tired. So I suppose unfortunately, for now that will be it. Thank you everyone so much for watching, and have a great day. Bye.